So you are going to need out a blue highlighter, a purple highlighter, a green highlighter, and an orange highlighter. So get out those highlighters. Blue, purple, green, and orange. You guys don't have a purple? Lily, you can use a pink for it. Or actually, they have an extra purple. I know, I'm stealing your purple. I'm so sorry. Okay. Okay. You ready to get started? So we will most likely be doing this like every unit, so you guys can kind of see. So word problems. A lot of times I see winces or groans when we talk about word problems. We're gonna make them less scary. Yeah, we're gonna make it less scary. So we're gonna kind of just like analyze, dissect the word problems, because this could help you even in just those normal regular problems, because a lot of times we're not reading the question all the way through. We're missing like key words that are in there and like valuable pieces of information. So first thing, under your paper, so on the under the, where it says Geometry Miss Davidson in the upper right corner, we're gonna make a little key with our highlighters, okay? A little key. So, the blue highlighter is the fluff. The fluff, like a cloud, the fluff. Just roll with me on it. I'll explain the fluff, but the fluff. We'll put in the colors and I'll kind of explain. So the description, or what it looks like, is the purple. So make that one like a purple. The numbers, any sort of numbers, are green. And what the question is asking, my orange up here looks yellow, but I promise it's orange. Okay, it looks really yellow, but I promise it's orange on my screen. It just looks weird. Okay, so what do all these things mean? What are we doing with this? So when you have a word problem, just like if you were to have a story that you're reading about in English class, okay? There's things in there that's like the fluff. It's like not really important to what the main idea is or what the article is saying or whatever you're reading is talking about. So that's what I call the fluff. So in word problems, you have maybe a little less fluff than in like a reading passage, but there's still certain pieces of information that's like, that's kind of a little bit of a fluff. Doesn't really like help us with solving the question. Yeah.
Can I write my name on it?
On your paper? Yeah. Yeah, you can write your name on it. The purple are description. So especially in the geometry word problems, they're describing a lot of times a geometric figure, whether it would be an angle. Right now we're dealing with line segments, so all of our questions are dealing with line segments. So we're gonna see description words or things where they're talking about, oh, it's a line segment, right? Green, all the numbers. So whether it gives you coordinates, whether it gives you an algebraic expression, all of that stuff. And then the orange, what is the question actually asking? A lot of times they ask us to do two things. Sometimes we don't do both of those things. Sometimes we only do one thing. So we really want to emphasize making sure we answer the entire question. Okay? So, example 1, Oakley and the lizard. Okay? Oakley is running in her backyard, chasing a lizard. Her backyard is large and she's running in a straight line. She runs from the garden bed to the grill, a distance of 2x plus 30 feet. Then she ran from the grill to the shed, which is x plus 60 feet. Finally, she returns from the grill to the garden bed at a distance of 3x feet. Her total trip is 390 feet. What is the value of x? and how far is each leg of like her trip, of her run. Okay? So when I'm looking at these questions, usually the easiest thing that you can point out and see is, well, what is the question asking? So with our orange, right, we're going to highlight our question, which is what is the value of x? How far is each leg of the trip? Okay, that's what our question's asking. That's what we need to solve for. Okay, there is a little bit of fluff in here, not like too much. I would say like the first sentence is kind of fluff. It doesn't really have to do anything with like us setting up our equation or anything like that. So Oakley's running in the backyard, she's chasing a lizard. Cool, we know that, but it doesn't really have anything to do with us setting up a problem to solve for x and to find out how far she's running. Okay? In this second sentence, there's kind of a descriptor word that goes with what we've been talking about with line segments, right? It says she's running in a straight line, right? That's like description, what it looks like. She's running in a straight line, so that's like the purple. And then we have all of our numbers. In this case, we have all these algebraic expressions. So we know we're going to be setting up some sort of equation. So we have this distance, 2x plus 30. We have x plus 60. We have 3x. And then it says her total trip is 390 feet.
Is x a number?
X is the variable.
Should I highlight 3x?
Yeah, like highlight the whole. If it's like an algebraic expression, highlight the whole thing.
Well, what it says, what is the value of x? Should I highlight the x?
No, you don't have to get that like into it. You have to highlight the x. So we have all of these pieces of information. All right. We know she's running in a straight line. She's trying to get this lizard with all of her might. We have all these distances. She's running from the garden bed to the grill, from the grill to the shed, from the she's running all over the place. We have to set up an equation. Does anyone know what our equation would be just from this information? Anyone want to tell me what the equation should be? No. Sophia? 2x plus 30. Plus
3x. No, wait, x plus.
Uh-huh. What's the last piece?
Equal
Plus. What's our last piece?
3x equal
Mm-hmm.
3.
Perfect. So our equation, kind of long, but it's going to shorten up. So we have 2x plus 30 plus x plus 60 plus 3x equals 390. Because these are all of the algebraic expressions for how she's like running through the yard, right? She's running through the yard and then she's running back and it equals 390 feet. Okay. What is my next step? Combine like terms, we can add the x's, so let's do that. If we add together all of our x's, what's that going to give me? 6x. Then what are we doing? 30 and 60. Okay. Subtract the 90. Good. Okay, so 6x is equal to 300. divide what?
The
The 6. So what should x be equal to? 50. Is x equal 50 my final answer? No. What else do I have to give?
You have to plug the base thing in the both x.
Yeah, so we're gonna plug in the 50 to all of our expressions here. So I have 2x plus 30. So 2 times 5 plus 30. Oh, sorry, 50. My bad. 2 times 50 plus 30. 130. So that's one of them. Then we have to do 50 plus 60. 110, good. And then what is the last one? 150, because we have to do 3 times 50. So 150. Ooh, my pen went all over the place. Okay. So now are we done? Yes. Yes, we are. Yes, we are. I'm trying to trick you. Yes, we are done. That's all that we have to do. So we have our x is 50. We plugged it all in. We got each leg of her running all around. Okay? Not so scary, right? Not so scary. We're gonna do 2 more. Okay? It won't be as scary. It's not so scary. Okay. So each of these examples has to do with things that we've been doing this unit. So the first thing was segment addition, right? Now we're gonna look at something a little bit different. Example 2 says, Jordan is walking on a straight path from his house to his friend's house. His house is located at point A, which is at the coordinates 2 and 3 on a coordinate grid. His friend's house is at point B, which is at 10 and 11 on the coordinate grid. Halfway there, Jordan stops at a park to rest. What are the coordinates of the park, assuming it's exactly halfway between Jordan's house and his friend's house? So, we go through. First of all, what is my question asking? What is my question asking?
What are the coordinates of the park?
What are the coordinates of the park? I'm just going to highlight the last sentence because it's all like one question, right? What are the coordinates of the park? Okay. Do we have any numbers?
Yes.
What are our numbers?
10, 11,
Okay, so we have point B, 10, 11.
point
And point A, we have 2 and 3. Are there any descriptor things in here that we see? Any like words that we're like, oh, that's like describing what the, something about the question? What? A straight path, love it. Is there something else? There's like one more, I would say, kind of.
Whose house is located on a coordinate grid? It stops at
Okay,
the park.
on a coordinate grid.
Stops at
Oh, I guess there's actually 3. There's one more. So he stops at a park, but there's something with where he stops at a park.
halfway.
Halfway. He's halfway. What does halfway mean to us with what we've been talking about in Unit 1? In the middle, what is it? Midpoint. We're talking about midpoint. Okay, halfway, aka midpoint. So this question, they're talking about midpoint, but they're not telling you, hey, midpoint. They're just saying halfway. You have to connect the dots, right? So if I'm on a coordinate grid and I want to know where the coordinates of the park are. And I know that the park is halfway. It's the midpoint between Jordan and his friend's house. What am I gonna do to find that coordinate? What do I have to use? X1 plus X2 divided by 2. Good. Good. Okay, so from the back, our midpoint formula, right? This is midpoint formula. We talked about this. So if we're on a coordinate plane, and we're talking about midpoint, we're on a coordinate plane, halfway point, right? We have to use midpoint formula. This, again, is on your reference sheet, so, but it's good to kind of have that in your mind. So then, what should we do next? Okay, so we gotta plug in our coordinates, right? They're giving us a point A and a point B. So remember, you have an X and a Y in each coordinate. Okay, so make sure that we're remembering coordinates. We have an X and a Y. Sometimes we're like plugging things in and we're like on a roll and we try to put an X and a Y together. It's gotta be the X's together and the Y's together. So we'll plug those in. So my X's are 2 and 10 over 2. And then my Y's are 3 and 11 over 2. But what do we have to do with these things? We have to add up our numbers on the top and then divide them. So we should have here 6. And then what is the other one? It's a 7. I know. I know. I keep doing it on accident. I don't mean to. So it's 6, 7. 6, 7. Okay? But again, there's lots of clues in this problem, right? They're giving us, oh, it's on a coordinate plane. We have coordinates, halfway point. It's a straight path. We're dealing with line segments, right? All of these things that you have to like pick out of the problem, like how you would in ELA or in H General paper where you're like reading an article. Or if you're in history class and you're reading an article and you're like, what is this saying, right? What does this mean? What does this mean? It's all connected. Okay, does anyone have any questions about example 2? I totally was like doing it and then we did it last class and I was like, gosh darn it. Why did I do that again? Just keeps popping up. Okay, so we'll move on to the last example. And then you guys are gonna practice. This one, you got a picture. So Javier walks from his home at point K to the internet cafe at point 0. If the school is at point W, is exactly halfway between Javier's house and the internet cafe, how many meters does Javier walk? So what is my question asking me to solve for? How many meters does Javier walk? Good. What are some descriptors in our question? Halfway, good. It says exactly halfway. This kind of first sentence is a descriptor. In this question, it doesn't necessarily say a straight path, but it says, oh, he's walking from his home, point K, to the internet cafe, point O, and they give you this diagram. Okay? Do we have numbers or expressions? 19p minus 5. 15p plus 23. Good, Emily. So, how should I start this problem? Okay, so Javier, he wants to know how many meters he's gonna walk from his home to the internet cafe. We know that the school is exactly halfway between his home and the internet cafe. So what do we have to do, Alton?
The distance from K to W equals the distance from W to O.
Okay, so from K to W, it's the same distance from W to O. So that means that this and this are equal. So that's how we set up our equation, right? So I'm gonna write it over here, 19p. I will move out of the way in just a moment. I know I'm in the way, I'm so sorry. Our equation, right? If it's exactly halfway, again, ding, 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 we have midpoint. The school is our midpoint. So then what is my first step when I'm solving my equation? What should I do first? Or what do we want to do first, Alton?
Put in parentheses around the 19p minus 5. And then
Wait, I'm confused about the parentheses.
What's the end of the parentheses?
Oh, the M is just for our meters. That's our measurement. Yeah. The M is just there, yeah. There's just, so anytime you have like a measurement in the, it's a good, because we're like, what is this M doing here, right? We have a P here, what's the M? So anytime they give you a measurement in these real world scenarios, they'll put parentheses around the algebraic expression, just so that you don't think that the M or like the feet is a variable. But no, that's good. The M is just meters, so what should we do here? So we want to add the 5, we can totally do that. Add the 5 to the 23. Okay, so now we have 19p equals 15p plus 28. Minus 15p, perfect. Okay. All right, what's our last step? Divide the 4. So what is p equal to? 7. Is that our final answer for this question?
No.
No. No. So what do we have to do?
Input in P.
So we have to put it into the equation, into P. So I'm going to put it in this first one, just so we can...
I'm scared.
Oh my gosh, my pen keeps doing this weird thing.
What?
So I know that I can take P, I can plug it into 19p minus 5, I can replace the P, right? What is 19 times 7 minus 5? Someone do it, tell me. What is it? 126, 128? 128. Is 128 our final answer?
You started scaring me.
No.
I said this go.
No, we have to add 128 divided by 128.
We have to add. Yes. Okay. So this 128 is only from K to W, right? Where is Javier walking? Where is he walking to from his house?
His friend's house.
The internet cafe.
He's walking to the internet cafe.
That was an internet cafe.
So when people didn't have Wi-Fi readily available in their homes, they had to go to an internet cafe or like a library to get on the Wi-Fi. Okay. Anyways, so because our school is our midpoint, right? From his house to the school is 128. So that means from the school to the internet cafe is 128. So we have to take 128 and multiply it by 2. So our final answer should be what? 256 what? Meters. You could just add the 128 plus 128, or you could just do 128. Yeah, that would work. Does everybody see what we're doing kind of here, our process? Does anyone have any questions, comments, or concerns before I let you pre?
Did you have to go to the internet cafe?
I'm not that old where I had to go to an internet cafe, but I did have to explain Blockbuster to people last year. You don't know? Okay, so you guys know the Anytime Fitness in the Public Plaza?
Yeah, I know what a
That
Blockbuster is.
that was the Blockbuster.
Yeah.
So when Miss Davidson was little, right? My parents would take me and my brother to Blockbuster, and like on a Friday, and we got to each pick like 2 movies that we could rent for the weekend, and we could watch. So you'd have to rent. So we didn't have Netflix. We'd rent movies.
Miss Davidson, the college football game with ball, and now the team came out of one to the line.
Yeah, look at those Buckeyes. Arch Manning looks awful.
Oh, 5, 6, 7.
I can't believe FSU won. I'm still like.
They're like the best team out there. Come on.
Okay, well, Hunter's a little bit delusional, so we'll get started on our practice problems. So, on the back of your paper, guys, on the back of your paper, there are 3 practice problems. They might look very similar to the problems on the front that you guys did. They're just a little bit different. So, on the practice problems, you are going to highlight, right, what the question's asking, descriptive pieces, if there is fluff, and then the numbers, and then you're going to solve. You have to highlight the practice ones too. Okay? You're going to turn this in at the end of class, no matter if you finish or not. Just try to get as far as you can. Okay? Do we all understand? Okay, get started. I will be around if you need assistance or you have questions. You need assistance?